Hello students, in the previous session you have understood the meaning of algebraic expression, polynomial, types of polynomial and the standard form of polynomial of degree n. Today in this session you are going to learn some more concepts related to polynomial. In the beginning, we shall learn value of a polynomial. Let us consider some polynomial p of x which is equal to x cube minus 2x square minus 2x minus 3. Suppose if I consider x value as 1, then p of 1 will be 1 cube minus 2 times of 1 square minus 2 times of 1 minus 3. Therefore, p of 1 is 1 minus 2 minus 2 minus 3. We get it as minus 6. This minus 6 is the value of polynomial p of x at x is equal to 1. Minus 6 is the value of polynomial p of x at x equal to 1. Therefore, whatever the value of the variable you substitute, we get the value of the polynomial. If the value of x is k, then value of polynomial will be p of k. So it means we are replacing x by k. Therefore, we get value of polynomial p of x for x is equal to k as p of k. Now let us study 0 of a polynomial. In our previous class, that is in class 9, we have learned value of polynomial as well as 0 of a polynomial. We were naming the 0 of polynomial as solution. Here is a definition. A real number k is said to be a 0 of a polynomial p of x if and only if p of k equal to 0. Let us take some of the examples to understand 0 of a polynomial. Let me consider one of the polynomial p of x is equal to 3x minus 2. To find the 0 of a polynomial, I will equate it to 0. Then I get 3x minus 2 equal to 0. So the value of x is positive 2 by 3. Now you just observe what is p of 2 by 3. P of 2 by 3 is 3 times of 2 by 3 minus 2. You cancel this 3, you will be left out with 2 minus 2 which is equal to 0. Therefore, 2 by 3 is 0 of p of x equal to 3x minus 2. This 2 by 3 is a real number. Let me take another example. P of x is equal to x square plus 1. To find 0 of p of x, consider x square plus 1 equal to 0. So x square will be minus 1. This implies x is minus 1 taken under root minus 1. This root minus 1 is not a real number, is no real 0. In this case we had a real 0. In this case we have no real 0. Let us see one more example. Let me take a polynomial as x square minus 2. To find 0 of p of x, consider p of x equal to 0, which means x square minus 2 equal to 0. We get x square as positive 2, x will be under root 2, in particular is plus or minus root 2. So it means positive root 2 and negative root 2. These are two roots. These two roots are real numbers. They are real zeros. Observe, the degree of the polynomial is 2 and we are getting 2 zeros here. Let us take one more example of a polynomial having degree 2. X square minus 7x plus 10. We know to factorize this. We had learnt in class 7th. So to find zeros, take x square minus 7x plus 10 equal to 0. This can be written as x minus 2 times of x minus 5. Simplify, you'll get this by factorization, splitting the middle term. So the value of x are 2 and 5. So there are 2 real zeros. In this case also we had 2 real zeros. We shall learn geometrical meaning of the zeros of a polynomial. We will do this by considering some of the examples of polynomial, a linear, quadratic and a cubic. Let me take some example for a linear polynomial. Say y is equal to 2x plus 3. To get exactly the geometrical meaning, I require to plot the graph of this equation y is equal to 2x plus 3. For that, we require the value of x and y. If the value of x is minus 2, the value of y is minus 1. If the value of x is 2, the value of y is 7. Let us plot the graph of these 2 points and connect these 2 points coordinates. We get a straight line. So it is a linear polynomial where the degree is 1. Let's plot the graph. On plotting the graph, we get the graph like. Look at the graph. This was the point minus 2 comma minus 1. This is our point A. This is point B. 2 comma 7. This A and B are joined with the help of a straight line. It's a linear polynomial. For a linear polynomial, we always get a straight line. What is to be understood here? We have to look at x-axis. On x-axis, there is a line intersected by y is equal to 2x plus 3. This line of y is equal to 2x plus 3 intersects the x-axis at minus 3 comma 0. This minus 3 comma 0 is 0 of the polynomial. 0 of polynomial 2x plus 3 is minus 3 by 2 comma 0. The reason is this y is equal to 2x plus 3 will satisfy minus 3 by 2 comma 0. If you substitute in this, we get 0 equal to 2 times of minus 3 by 2 plus 3. We will be getting 0 equal to 0. Hence the left hand side and the right hand side are equal for minus 3 by 2 comma 0, which means the point which is obtained by the intersection of the given line with the x-axis will be solution or 0 of the polynomial. Let me take another example, which is a quadratic equation, x square minus 3x minus 4. This quadratic equation has got degree 2. When we simplify this by equating it to 0, we will be getting 2 zeros. Do we get 2 zeros on the graph? For that, let us take values of x and y. This first column is x and the second column is y. These are the different values for x and y. If the value of x is taken as minus 2, we will be getting the value of y as 6. Similarly, the other coordinates are obtained. If you plot these coordinates, we get a graph, a beautiful graph, which is called as parabola. I had mentioned it in our previous class, class 9, that this type of graph is called a parabola. Y dash, y axis and x axis. Look at this graph of this equation. This equation, x square minus 3x minus 4, on plotting we get a U-shaped curve. This curve is intersecting x-axis at these 2 points, point A and point B. This point A, which is minus 1 comma 0, and point B, which is 4 comma 0, these are zeros of y is equal to x square minus 3x minus 4. You can verify if you substitute minus 1 comma 0, this value is satisfied in this equation. The same is the case with the coordinates 4 comma 0. Since the graph of the equation x square minus 3x minus 4 cuts the x-axis at 2 distinct points, there will be 2 zeros of a polynomial. So there will be 2 zeros. In the previous discussion we had that either there will be 2 zeros or there will be no zeros, because no real number will exist. Look at this. There will be always three different cases. The case 1, here the graph cuts the x-axis at two distinct points A and A dash. The coordinates of A and A dash are the two zeros of the quadratic polynomial ax square plus bx plus c. In this case, just look at the first figure in this. We have 2 points which are there towards the right side. These are the 2 points A and A dash. They are 2 zeros. In this case also we have got 2 points A and A dash. They are 2 zeros. So 2 zeros will be there for a quadratic polynomial. This is one of the cases. 2 zeros will be there for a quadratic polynomial. Look at this case. Observe the graph very carefully. The graph cuts the x-axis exactly at one point, that is, at two coincident points. So, the 2 points are A and A dash of case 1 coincides here to become only 1 point A. Actually, you have come across some equations like x square let me take one of the examples, say y is equal to x square minus 2. To find the values, let me consider this as x square minus 4 equal to 0. So we have x plus 2 into x minus 2 is equal to 0. So x values are minus 2 or plus 2. So there are 2 zeros. Zeros are minus 2 and plus 2. So on plotting we will be having both the zeros on x-axis. Look at this case. Here the graph of x-axis cuts exactly 1 point, that is at 2 coincident points. What does this mean? If you have an equation, say y is equal to x square minus 4x plus 4, we have learned identity. This is nothing but x minus 2 whole square identity. Isn't it? Yes. So it can be written as x minus 2 into x minus 2 is equal to 0. Value of x are 2 and 2. Here both the zeros are same value. So the point A and the point A dash coincide. Here also point A and A dash coincide. Therefore, the x coordinate of A is only 0 of quadratic polynomial ax square plus bx plus c in this case. Look at the third case. Here we have parabolas. Do we have a point of intersection of the curve with x-axis? Do we have it? No, we don't have. Here the graph is either completely above the x-axis or completely below the x-axis, which means we don't have any point of intersection of the curve with x-axis. So there will be no zero. So there won't be a zero of quadratic polynomial for such type of an equation. Say for example, y is equal to x square plus 2 if you take, x square plus 2 equal to 0 you will equate. This will be plus or minus root of minus 2 root of minus 2 is not a real number. In such cases, there won't be a real zero. There is no real zero for such type of an equation. Therefore, we can say that for a quadratic polynomial, there may not be any zero of polynomial. There can be only one zero of polynomial. At the most, there will be two zeros of polynomial. Look at this particular graph. This is a graph of a cubic polynomial. Observe where this curve of the graph cuts x-axis. The curve of the graph cuts x-axis at these 3 points. They are, let me write this as point A, minus 2, 0, point B, 0, 0, point C, just 2, 0. So there are 3 points. So there are 3 zeros. So 3 zeros are there for this particular cubic polynomial. In your examination, you will not be asked to plot the graph of either a quadratic equation, quadratic polynomial, or a cubic polynomial. Look at this next one. I have taken y is equal to x cube. In this particular case, at 0, 0, we have curve meeting x-axis. So that is 1 of 0. So 1, 0 of polynomial is 0, 0. Do we have other two? We don't have. In this particular case, we have coincident points. Look at the graph of this particular cubic polynomial. This cubic polynomial is meeting the x-axis at 0, 0 and at 1, 0. So we are able to see there is one point 0, 0 and another point which is 1, 0 on x-axis. So these are zeros of y is equal to x cubed minus x squared. What does that mean? If you solve this equation, we get x squared common, we get x minus 1. By equating it to 0, we get x square equal to 0 or x minus 1 equal to 0. So it means x value is 0, 0 and 1. So there are 3 zeros, but these two values are same. So two coincident points and one more point. Finally, we can conclude that at the most 3 zeros are there for a cubic polynomial. In other words, any polynomial of degree 3 can have at most 3 zeros. Now you are in a position to answer this question. There is a question given here. The graph of y is equal to p of x are given in the below figure for some polynomials p of x. Find the number of zeros of polynomial p of x in each case. Look at the first figure. Let me write it here. In the first figure, how many zeros are there? Number of zeros. There is no zero of the polynomial. In the second figure, we have one zero. In the third figure we have 3 zeros. In the fourth figure we have 2 zeros. In the fifth figure we have 4 zeros. In the sixth figure we have 3 zeros. Look at this. It's a linear graph. It's linear. A linear polynomial will be having at the most 1 zero. In this case it is 0 number of zeros. This is a curve. This curve is not a quadratic polynomial. The reason is, in a quadratic polynomial we will be always having either this shape or this shape. These two are called as parabola. This is some polynomials, a cubic polynomial. We have got 3 number of zeros. In this case, fourth figure, we have a parabola. This is for a quadratic polynomial. This fourth figure is a quadratic polynomial. For a quadratic polynomial, we will be having at the most 2 zeros. Look at this fifth figure. Interesting. There are 4 number of zeros. This 4 number of zeros will be a minimum number of zeros for a biquadratic. Sorry, maximum number of zeros for a biquadratic polynomial. This is some polynomial which is having